Let's talk about JPA. So up to this point, we've been interacting with the database. First, we started interacting using just a client where we manually logged into a database, and we sent SQL commands, right, to insert, to update, to delete, to select data by us typing SQL commands right on the console. And so the next level of abstraction that we introduced was, well, how about instead of having to be right on the console, what if you want to be able to programmatically access that data, or we might want to make it available to outside folks that not necessarily have direct access to the console, don't necessarily need to have ability of sitting down at the console, or even rights or logins or the authority to have direct access to the database. So we introduced last time we met using JDBC, Java Database Connectivity, as an API for being able to programmatically interact with the database, right? So that we can wrap data access around an application, and then programmatically be able to send these commands using JDBC. One of the things that was appealing by using a JDBC was that it made us independent of the vendor, right? That as long as all the vendors adhered to the JDBC API, we could write one set of code that would be able to interact with any vendor, right? And that's a little bit pie in the sky. Some of the vendors have very specific idiosyncrasies that they don't necessarily make available in all their APIs, and we tend to, even though we try to stick to some of the standard SQL that is common across all the vendors, oftentimes these vendors will convince us to use some features that are specific to that particular vendor, and that defeats the purpose of using JDBC, of writing a set of one single set of code that would run throughout multiple vendors. So the next level of abstraction was that, is going to be the JPA, or the what are referred to as object relational mapping technologies, right? And the idea here is that we would like to be able to think of the database as if it were objects, right? As if each record in a table would be some instance of some class, right? That is represented in memory, right? We sort of did this last week using JDBC, right? We were able to retrieve data and instantiate a class and load it, right? And populate it with data that we read from records, right? So we were already able to do that, yes. And the way we achieved that was through writing what we call data access objects, right? Data access objects allowed us to encapsulate the interaction with the database with some of the more common ways that we interacted with, right? Writing all the CRUD operations, the create, read, update, and delete, and any other operations would be encapsulated in a DAO, in a data access object. Make sense? Now, if you write enough data access objects, one for this table and another one for the other table, you'll find that you start finding a pattern, right? That they all look the same. All these data access objects all look the same. They all have a create, a read, update, had the more common operations, plus additional operations that might be very specific to a particular table or set of tables. But for the most part, right, they are very, very similar to one another, right? So the difference between creating an instance of an actor or a movie or a user or a course or whatever, right? The difference is that, well, the table is different, the fields are different, right? The data types are different, but the algorithm is always the same, right? You get a connection, right? You use a SQL command that you have to usually you have to parameterize, right? And then you send the insert command, or the select command, or whatever. Right? So once you've written so many of these, you start finding a pattern, and us as software engineers, right? We are, that's what we're looking for. We're looking for patterns, and whenever we find a pattern, we say, well, can this be generalized? Can we generalize this pattern right? So that we don't have to write this again, right? Can we write a general DAO? Can we write a generic DAO, right? That we could parameterize and can let it know, well, here's the schema, here's the table, here's the fields, here are the data types, right? You just configure yourself, and you can interact with any table. Yeah. Right, so that's the idea of an object relational mapping technology, right? Where we can parameterize all these design patterns of data access objects and whatnot, all these singletons, and encapsulate it so that it can automatically, discover and configure itself for any table, right? And the only thing that it really needs is as a parameter, it needs the schema. It needs to know what the table is. It needs to know what the fields and their data types. That's all it needs to know. Make sense? All right. So JPA is one of several solutions to this or implementations of this idea. It happens to be Java's version of an ORM. But if you're using .NET or any other framework, right, those frameworks will have an equivalent, right, implementation of an ORM, right? That basically what they allow you to do is, hey, here's a Java class, right, and presumably this Java class has a mapping to a table in the any right? And presumably we think about this in UML as a very high level where the UML can be represented in any number of ways, right? It can be represented in a relational database schema. It can also be represented by a Java class, right? It can be represented by a JSON object, all sorts of ways, or XML schema, right? It has many, many different representations. So by thinking about it in the conceptual level, now we can think about it, well, if you give me a Java class, well, that might as well just give me a relational schema, right? I can derive from this Java class the name of the table, right? The name of the table will be whatever the name of the class is. And all the fields, presumably, will be the names of the properties of the class, yes? And their data types will be the data types from the Java class. Right? Presumably, I can map these one-to-one. Not quite, but more or less. So JPA allows you to do that. It allows you to take a Java class, right, configure it, and say, hey, take this Java class and map it, generate for me the schema. Right? So I don't want to have to deal with the schema anymore. Right? Automate this all for me so that I can think at a very high level, right, in just a Java class. Right? Now this works quite well. There are certain pitfalls and gotchas in that the object world doesn't necessarily map neatly into the relational world. Right? We already saw some examples a couple of weeks ago when we considered inheritance, right, or specialization, that there is no one-to-one mapping on how do you represent generalization in the object world, and how is that converted into relational world, right? And we saw that there were 3 different ways of doing it. Actually, there's a couple more, but we looked at the 3 main ways that folks consider on mapping these 2 worlds, yes? And there's many, many different other conundrums, right, or things that we need to decide on how is it that we are going to represent something in the object world that it's much more expressive. Right? You can do all sorts of things in the object world that you can't do in the relational world. Right? So how do you bridge this gap? Right? This gap oftentimes is referred to as the impedance problem. There's an impedance. There's a challenge of mapping these 2 worlds, going backwards and forwards between these 2 worlds, right? And we need to just be aware of them. Okay. All right. So let's talk about JPA.